Hello everyone and welcome to our digital days. My name is Markus Eberle and I will moderate this presentation today. We are very pleased that you took the time to participate in our presentation today and in our virtual conference. The topic of today's presentation is machine data made accessible. Thank Bluetooth and mobile apps. Our speakers today are Ruckes and Michael Lang, who are working in the field of software development and wireless connectivity and sensors. They will hold today's presentation and also answer your questions. Before we start the presentation, I would like to point out one thing. You will be muted during this presentation today, but nevertheless, you can ask us your questions via the chat function. You will find that in the webinar control panel. I think it's called questions. Our presentation today will be about 30 minutes long. The question and answer session later on, we have scheduled 5 to 10 minutes for that as well. And if you have any other questions left after the webinar, just email us at exhibition@we-online.com. As well, I want to give you the hint, at the end of the presentation, you will get the link to a feedback survey. Of course, we would be pleased if you take your time and fill out the survey to help us to improve our virtual conferences and our digital events. You will also receive the link to the presentation you will see the next few days, and the recording will be available at our website shortly. So now I will hand over to our speaker, Michael, and I wish you an exciting presentation.
So also from our side, warm welcome, and we are happy that you participate in this topic today about the Bluetooth connection, how to make machine data accessible. And I want to give you a short overview what we want to talk about today. First of all, a short introduction about Bluetooth in general, what is important to know, and then to come to an example application. What is the idea? Why is Bluetooth a nice possibility to connect to a machine? How an app is invented is the next point, what you have to consider and what are their points to know. And in the end, also a short part about the Bluetooth solutions from Würth Elektronik. And in the end, of course, the questions you send in the question tool in the webinar. Let's start. Bluetooth is well known. It is invented in 1996 by Intel, Ericsson, and Nokia, and it's somehow the standardized communication interface. It was in competition to infrared in the beginning, and Bluetooth was winning this fight. And now you see it. I wanted to say in nearly every smart device, but that's wrong. It's in every smart device integrated and lots of other devices, of course. Bluetooth at all consists of different versions. You could say different standards because they are not compatible with each other. So there is Bluetooth Classic, Bluetooth Low Energy, Bluetooth Mesh, and LE Audio, and they are quite different things, and you cannot easily connect one to each other or cannot do it at all. It depends. First, we want to have a closer look to the Bluetooth Classic, as it is very familiar and used. For example, the best one is in your car. The Bluetooth connection to your smartphone is done by Bluetooth Classic with the possibility for hands-free communication, and very, very popular in this way. It uses 79 channels with 1 megahertz bandwidth and has a relatively higher power consumption than the other ones following. There is 1 master and up to 7 slaves, and very important for the industrial usage is the serial port profile. It is defined by the Bluetooth itself and had or put the possibility for a serial communication, so to say a cable replacement very easily with Bluetooth Classic. It was the first part or standard in Bluetooth and is really used also today. But in the graph on the right side, you see it is decreasing and low energy is increasing and takes the part from the Bluetooth Classic. The next one is Bluetooth Low Energy. It was released 2010, first with Bluetooth 4.0, and it's really a difference. It uses 40 channels with 2 megahertz bandwidth, and so to say, or it's easy to see, this is not able to communicate with each other as using different physical standards. The main difference really is shown in the name already, the low energy. Bluetooth Classic had a problem to consume a lot of energy, and low energy is really an alternative to that. And this is reached by sleeping a lot. That's the best. You know, all of you know that also. To have a sleep and the data connection is a very short part. You sleep a time, and there Bluetooth Low Energy has the possibility to save energy. There are 2 modes of operation in the Bluetooth Low Energy part. The first one is a non-connection orientated communication. It's a broadcasting, or it's called beaconing in the Bluetooth world. And important to know is that there is no security or encryption usable, as anybody should be able to receive the messages. The beacon size also is restricted, and to know is also important that there are 3 advertising channels used. You see it in this graph on the bottom left side. The red channels are the so-called advertising channels, and there the beaconing is or works. The other channels are used by the connection-orientated point-to-point communication. There is always a master needed who starts the conversation, and this is called in Bluetooth the central role, and it's typically the smart device. On the other hand side, there is the slave. It's called peripheral in the Bluetooth world, who sends the data, for example, and is typically the device you want to connect to your smart devices. The two parts negotiate the communication in the beginning, what data rates are possible, who is transmitting in which frames, and also for optional low energy features, they are handled who is able to do what, and they do it in the negotiation phase. And why Bluetooth is so successful is in this frequency hopping part. There are 37 channels used for the data connection, and there is a frequency hopping integrated. So you jump from one channel to the other, and you see it here in this example. We have showed the Wi-Fi channels 1, 6, and 11, and there are between there are the Bluetooth channels, and so there is always a space where you can communicate with Bluetooth and are not disturbed from Wi-Fi, for example. And so it's a very robust communication, and it's one of the reasons why Bluetooth is so successful. Another very important point for Bluetooth is the listing process. So every Bluetooth device has to be listed as it is a licensed communication protocol. This listing consists of two parts. One is the qualification. I would say it's the testing and measurement that the device can talk Bluetooth and is able to understand other Bluetooth devices and that they can connect. So that's the very important point in Bluetooth world, that Bluetooth parts can communicate with each other. Of course, there are limits because not every device supports every function, but in some ways, every part can communicate with the others. The second part is the declaration, and there is no measuring needed. It's only paperwork, and you have to do what you or you have to do it to get this, I would say, somehow the permission to do it and to use it. And actually, it costs around 9,600 US dollars to get one device series be used in the Bluetooth world. Responsible for that is the distributor. Don't let or to clarify it, it's the manufacturer, you can also say. In German, it's the Inverkehrbringer. And if there is another party in between who only buys the part and resells it, so the reseller, he is not responsible, of course. It's the manufacturer who brings the part on the market. He is responsible for this listing. One point which is important, you see it on the right side, there are different paths you can follow to get this listing. One, of course, is you do the qualification and the declaration by yourself, starting from the scratch, for example, with a Bluetooth chip, doing everything on the part, and then you have to do the whole qualification and also the declaration process, including the measurements and everything, and also some fees. It's, of course, very high effort, but in the end, you get a Bluetooth listing. Another possibility, which is somehow easier, is you start already with a qualified product. For example, a Bluetooth module from Würth Elektronik or other manufacturers. They have, or we have, qualified modules, and so you do not have to do the effort, the money, and also the time to qualify your product, but you get in this declaration process and have to do only the paperwork. So you take the QD ID, and then you get relatively fast get this listing ID, and then it's easy to use it. The third part you can use is somehow an update path. If you have once paid the $9,600 and you have listed, let's say, measurement device A, and now you invent a measurement device B, you do not have to do it again, but you can update the existing listing, and then you don't have to pay anything and put it in the same listing. Therefore, it is important that you use the same Bluetooth software and hardware, of course, that it could be integrated in the same listing. And also you have to be the same distributor, so manufacturer. In this case, no additional fee has to be paid, and that's the easiest way. And you can, of course, use it in every device you want to bring on the market and put the same Bluetooth hardware in, and then you can use one listing for all devices. As this is somehow complex, we also have an application note about the whole Bluetooth listing process and guide who helps you to find out what is to be considered and what you have to do to get a Bluetooth device in this regulatory stuff correctly on the market. The last point about the Bluetooth general information is the depreciation policy in Bluetooth. You see, every Bluetooth version will sometimes scheduled for depreciation, for example, after 10 years after the release. And here in the table, you see we have shown from version 4.1 to 5.3 upwards. The versions below are already deprecated for years, and you cannot use them. That's the important point for new listings. So you can use it if you have already a listing, you can bring it on the market, and you can, of course, build the devices on and on and on. There is no limit, but you cannot do a new listing then. And if, as you see, also the standard 4.1 is deprecated for 3 years now, and the following standards are have also a time that's not very fixed. It can be adjusted. The Bluetooth SIG, the special interest group, it's the owner of the licenses, they have a look on it, and sometimes they change the date and set it on a later one. But it's important to know that if you want to invent a Bluetooth application, you have to have a look on the version you want to use. Perhaps there is a very cheap module you find somewhere on the market. Perhaps it's an older version and you cannot list it anymore. And so it's recommended from our side to use newer versions. So with the 5.x versions, you have more security for the future, that you can list it even if your development time increases a bit. Okay, so this was the first part round for the Bluetooth generals. I want to suggest, if there are any questions, you can send them in the webinar tool, and we have a look on that on the questions later on. And now we want to come to an example application, how to access a machine, and this is very easy with Bluetooth. For example, for the parameterization of a machine, if you build it up and you want to set some figures. Of course, the service interface is one point that the service team comes up, and they have a smart device, a tablet, and can easily connect to the machines and see how often something was done or something, and you can have an easy access without opening any parts of the machine. You can easily access. Of course, the operator has the possibility perhaps to see something in the machine, or to set some parts inside. There is a recalibration as option, and of course also a firmware update of the machine could be done by Bluetooth. And so it's a really wide range of possible options you can use with the Bluetooth connection. In general, you have to consider every wireless connectivity connection is always a trade-off between range, data rate, and energy consumption. And this is an important point. In German, you would say there is no eierlegende Wollmilchsau. You cannot have everything in one solution. There is always one dependency on the frequency or the wavelength. The higher the frequency is, and it means that the wavelength is shorter, you have a higher data rate, but also a shorter range. In the diagram, you see it in this blue triangle. You have a higher data rate, but a lower range. In this module, we have here a 2.4 gigahertz RF module shown. Higher data rate, lower range because of the higher frequency used. On the other side, if the frequency is low, the wavelength is longer or bigger, and then you get a higher range, but also a lower data rate. This is the red triangle. You get the range increasing, but the data rate typically is decreasing. This is one dependency on the frequency. Another one is about the power consumption. If you compare two 868 megahertz systems, for example, if you have a higher output power, you get a higher range, but also a higher energy consumption. On the other side, if you have a lower output power, you get lower energy consumption, but also a shorter range. This you can see in this comparison of the red and the black triangle. Both are 868 megahertz systems, but the black one has up to 27 dBm output power and has a very high or high range or long range, but the energy consumption, of course, is also very high. Comparing to the red one, the energy consumption is much lower. You have 14 dBm in this case, but also the range is not so high. And this is always a trade-off. As I said, you have to consider what is the solution I need or what is my application to find the right technology and how to use it. On the next slide, we want to show an example communication, how it could be possible to communicate to an or between two devices. There is always a host controller, and there is the application integrated. If you now want to communicate to an RF module, like Würth Elektronik has it as a standalone all-inclusive module, it's a box, a black box, I would say, and you don't have to do anything inside. It's fully complete, and you don't have to do something, but only access it. For example, if we want to send a hello world, the application processor starts this sending process, and then there is a request started to the radio module, and to translate this, there is a SDK available to easily invent it and bring it into your device without being an RF specialist. You can use it like many other communication parts. As we have requested this sending process, the radio module sends out the data and confirms the sending, and this information comes back to the application processor, and he gets the answer, send was successfully. On the other side, the RF packages arriving, the radio module indicates the communication, and the hello world comes as callback to the application processor, and also the RSSI value is transmitted.
Exactly, and this is where I come in. So hello from my side, my name is Jens Ruckes. I'll take over for a couple of minutes at least here, and for sure you will ask yourself, okay, on the right side I have now a host, but we are quite talking about smart devices right now. So let's exchange the host into a cell phone, for example, and let's think about that. So each cell phone will need an application on it to run the corresponding radio protocol and access the data that's available on the radio itself. So Michael, hand on. Next slide. Exactly. So first of all, we have again a look at the host integrations on the top right corner. So as said before, we have a wired communication interface between the radio module and the host. We have some additional GPIOs inputs and or outputs to, for example, wake up the module out of sleep, or to trigger some events, or get a message or an indication from the radio module that there are data available that were received previously. So yeah, that's what's happening here. So pretty much basic stuff. The integration into your end system. Now you could ask yourself, okay, so the radio module, I mean, it's quite small, yeah. So get along, Michael, one click. And yeah, so typical sizes of Bluetooth Low Energy modules are somewhere in between 60 to 100 square millimeters. So this is quite small, and if that's enough for my application, that would be too easy, wouldn't it? So one general rule of thumb is that each antenna on the module needs a ground plane as a counterweight to the antenna itself, which is typically in the size range of the module itself. So could be on the bottom side of the radio module or on your host PCB, for example. On the other hand, you always need a so-called keep out zone, which should be metal free. So to not have a Faraday cage effect and get the radio waves out of your device, you want some areas, so 3D areas, not only 2D as shown here, without any metal that could interfere with the radio waves. Yeah. So again, a general rule of thumb is that you have lambda divided by 10, a distance from the antenna free of any metal, which would result in roughly 300 square millimeters. So it's not only the area you need for the radio module on your host PCB, but also you need to consider some keep out zones and for sure material of the housing and stuff like that. Yeah, just to get a adequate radio range at the end in your system that for Bluetooth Low Energy purpose could be in the range of like 10 to 20 meters, which is a so-called personal area network there. Yeah, so it's really easy to mess up your radio range with not having a look at some basic rules. So please be aware of that when you design in systems. Check also your housing, not only the pure PCB on the table or whatever, but yeah, it's quite easy that radio range is reduced by a factor 2 or 4 because some metal flakes are in the housing materials or whatever. So that's yeah, a general thing to watch out in a design of a radio module. Okay, so coming to the smartphone side, and we are concentrating on Bluetooth Low Energy on the next 2 slides. So let's have a look at the protocol. So quite important to understand and to know is that Bluetooth Low Energy defines until a certain layer a standard setup of protocols and layers. And these are interoperable in between all radio products using Bluetooth Low Energy of the same standard version. So general thing is Bluetooth 4.0, as Michael in the very beginning introduced, was introduced with version 4.0. In the meantime, we are at 5.3. So what happened? Pretty much all additional features that came in are optional. So you need to consider your target application, and this includes the cell phones that should be used. Yeah. So we have 2 main cell phone manufacturers with using Android or the Apple devices, and both of them have dedicated sets of functions, rules, recommendations to work the best. So what we see here is we have in the 4.0 part, we're starting with 41 bytes physical data. That means this is the size of the radio packet. And coming off the 41, again, assuming backwards compatibility to the very old standard, we take off an overhead of in total 21 bytes. So counting all 3 layers that are defined by the Bluetooth standard itself. So what's over 20 bytes or 41, like 50%, a bit more than 50% overhead. That's quite harsh to get your data over. But yeah, again, most of the overheads is defined by the Bluetooth standard, and the best thing you can actually do is get a newer standard and use more data, so bigger radio packets. Yeah. What we do from our side is we put a little overhead as a manufacturer-specific profile onto that Bluetooth stuff to address something like our GPIO control and differentiate in between different data packets. So this is a little overhead. We'll see in the next slide also when we come to a live, or not live example, but to a real life example that's using our application. So what we see here is a demo application. You can get the source codes in the corresponding links or the apps in the corresponding QR codes. Feel free to test them and use the source codes for your application, which is, as you see, available for Android and iOS as well. What we see here in the example is the WE Horticulture app, which is the LED control. For sure, once connected, we'll see data coming from the LED board or going out. In this case, this is an example for receiving the initial status of the LED control directly after connect to it. So we see in the yellow or orange marking, we see the 1 byte overhead, which is hexadecimal 01, which indicates data, and then some sort of protocol is implemented. And spoiler alert, it looks like it's 5 channels and having a PWM value. So that's what's happening here. Above we see the GATT profile number, which is a 128-bit number. So this would indicate the type of the protocol that's used for the data. You can get these numbers on a web page, register your numbers and get assigned some numbers for you to your free use. And these numbers or the protocol that's used is manufacturer specific. So unless you have a GATT profile that's defined by the Bluetooth SIG and therefore to be used by anyone who uses that number or protocol, everything else is manufacturer specific. So you can't easily take a manufacturer A and manufacturer B and let them talk with each other. This is going up to that GATT layer, but not necessarily any step further because of the different manufacturer specific profiles, unless you implement on both modules for sure the same profile, which is possible too. And this is something you need to do on the application for sure. You need to register this profile you want to receive or send data to, and for sure make a bit of a parser that's knowing the protocol and can interpret the data. And in this case, it is possible to show just the PWM values as sliders. So it's easier for the customer than all these binary or hexadecimal data. So you just have the sliders and can move it, and the LED reacts then in the corresponding way. Yeah, so that's the application part. Again, source codes are available, feel free. And I'm not that much exciting, but a quick list for your reference for recommended resources regarding application development for smart devices. So could be Windows 2 and not only Android and iOS. Yeah, feel free to have access to this stuff. They include some valid and important tips and hints, some timing values, for example, that should be used, especially for Apple devices. There is quite a big restriction on which values to use for timing, packet sizes, stuff like that. So have a look, especially at chapter 40, if you consider to talk to an Apple device. Yeah, so that's the part for app development. I guess, Michael, next slide is you again.
That's right. Very short, we want to show what Würth Elektronik has in this Bluetooth section. We have so far 3 modules, I would say, in the Protoys series: Protoys 2, Protoys 3, and Protoys E. And they have different advantages and disadvantages. But what I want to highlight is that all modules are conform, and here for CE for Europe, FCC for US, IC for Canada, TELEC for Japan. And with these certifications, you can use it nearly on whole the world, because most countries say if you are conform with FCC, you can get in this market and pay 10,000 euros or something. So it's easier for you to get in the market. It should only be a short overview. In general, our Bluetooth or our RF modules or solutions always have a few benefits for you. The first is it's a full service product. There is hardware and firmware integrated. As I said before, it's a standalone all-inclusive module. So you don't have to do anything on the module. So it could be used very easily. Software parts as the software development kit and software tools are available, and the software could also be individualized if necessary. The configuration of the module is very important to be flexible and to set it to your application. And in all these parts, there is technical support for you on the hotline or on the phone, in virtual or in personal meetings. We can help you directly, and I think you know that this is very useful. Of course, there are evaluation boards and kits and USB sticks available to have an easy hands-on and starting point. And as I said before, a very important certification and conformity of the modules. And what you have in Würth Elektronik world always, small packaging units, no MOQs, and also a long-term availability. And to come to an end, a very short overview of what we have in solutions in wireless connectivity and sensor world. GNSS, GPS solutions, Bluetooth Low Energy, we have talked about today. Wi-Fi is always also a solution, proprietary, as it means a non-standard protocol, and very flexible and flexibility to adjust to your application. Wirepass is a solution for bigger mesh networks, and wireless M-Bus is a metering standard. And on the other side, sensors, MEM sensors, so they are calibrated and compensated fully for temperature, humidity, absolute differential pressure, and acceleration. So this is what we have here, and you have heard a lot about Bluetooth today, and we hope this helps you and are now interested in your questions. If you didn't send them in so far, you are free to do it now.
Yeah, so thank you, Michael and Jens, for your interesting presentation. At least I found it very interesting. Thank you. So yeah, as you have said, now we would like to turn our attention to your questions. And yeah, we already got some questions. So yeah, let's just start with the first question. So can any Bluetooth low energy device speak with each other?
Yeah, let me get into because that's quite the topic we saw on one of my slides. So in general, as they are using the same radio, all Bluetooth Low Energy devices could speak with each other if the protocols are A, either standard compliant, so defined by the Bluetooth SIG, and B, for sure, if so the requirement is both partners need to speak the same protocol. That's the basic thing. And that can be a manufacturer-specific protocol or a protocol provided by the Bluetooth SIG, given the fact that for sure you can decide to not implement a protocol defined by the Bluetooth SIG on your device because you don't need it. So that's a tricky question. A general rule of thumb is that you should expect, if you take two manufacturers, that they don't speak with each other out of the box, meaning data into device A coming out of device B is not an easy thing without adoption.
Okay, thank you very much for the explanation. Then let's go on with the next question. Are there experiences to use Bluetooth communication from within metal device housings and like slot antenna, etc.?
Yeah, I mean, the rule of thumb, again, Faraday effect is a bad thing if you have radio transmission. So it's most probably it's some sort of trial and error if you have a metal housing. Ideally, you have some sort of slots that are suiting for the radio wavelengths, or you have some plastic inlets, stuff like that. Or for sure, you can use an external antenna, for example, some coax sockets that can be given out through a drill in the housing and have an external antenna. So there is experience. The easiest way is, to be honest, the external antenna. But I mean, not in any case you can make a hole in the housing and have, for example, humidity in it. So that's quite up to the specialists for the application to decide. And for sure, we try to help wherever we can to reach the best radio range.
And of course, it depends always on the application and what you want to realize. If you want to send out Bluetooth for 10 centimeters, it's another question than if you want to say I want to send Bluetooth for 100 meters. And so this is also depending on the application, of course.
Mm-hmm.
Okay. Thank you, both of you. So regarding to the time, we have time for some more questions, but just a hint, if we can't answer your question now, we will answer it later on via mail. And you can also just email us at exhibition@we-online.com. So yeah, let's go on. What about security options for Bluetooth communication? How secure is a Bluetooth link?
Yeah. In principle, security can be negotiated in between two devices during the connection buildup. So if devices decide they want secure communication and the connection is happening, so for example, as Michael introduced, in the beaconing mode, there is no security concept implemented because it's a beacon, it's a broadcast. For sure, you can somehow obstruct the data that you're sending. For sure, it's your protocol. You can put anything in there. But in a connected way, there are security profiles which can be enabled. And for sure, if both devices support the selected profile, and both devices enforce it. So you also can support the security, but not necessarily require it to be active. So that's something that needs to be enabled or ensured on both devices, that a secure connection is also built up, which will add some more radio packets in the negotiation phase during a very start of the connection. Or if you do a bonding, this information, once a secure connection happened, is stored in the non-volatile memory of the modules and can be reused on a later reconnection. So then additional packets are not there. Security modes that are available are for sure defined in the Bluetooth core specification. Yeah? So these are available there. So ranging from so-called just works, which is using internally 6 times number 0 as a pin, to some very advanced stuff with long keys.
Okay, so thank you very much. Yeah, then regarding the time, yeah, I think we are finished with the presentation, but I see there are some questions left, and yeah, we will answer them later on via mail. So just a hint from my side, the next session will start at 11 a.m. and it's about Connect from Anywhere, surprise pre-announcement of a global connectivity product. So also in the range of radio modules. Yeah, be there. So thank you very much. Also, thank you very much again, Jens and Michael, for your interesting presentation today. I hope you enjoyed it and you enjoy our digital days. Thank you and goodbye.
Thank you for participating.
Thanks
and
also.
have a nice day.
Yeah, thanks from my side too. Have a nice day. Stay healthy. Bye-bye.
Bye-bye.
Bye.